In this video, I will talk about dielectric material. Small particles in dielectric material are atoms. If there is no external electric field, electrons move around the nucleus symmetrically. If external electric field exists, electric field push nucleus to the direction of electric field. Electrons are pulled to opposite direction. This can be modeled as 2-point charges, a negative Q and a plus Q, separated by a distance d. As shown here, this is called electric dipole, denoted by small p. It's a vector, the magnitude is qd, and the direction is pointing from the negative q to the positive q. The unit of dipole is coulomb meter. Here how it looks like in the dielectric material. Here's the electric dipole moment of each atom. Look at macroscopic structure of dielectric. We define electric dipole moment as its density, or the number of electric dipole moment per cubic meter. This quantity is called polarization. If we look at the whole piece of dielectric, this is an average polarization of the whole piece. If we want to find the polarization at a point, we need to let the volume delta V approach zero, or the volume only cover only one point. This gives polarization at each point of dielectric. We can see that polarization is a function of position or a function of x, y, z. If we have charge density rho sub V and a dielectric together, how do we find electric field produced by the charge density rho sub V? We cannot use the equation from Coulomb's law anymore because the equation is for unbounded free space. The whole space must be free space, but now the space includes dielectric material. We need to replace dielectric with its equivalent charge density. The equivalent problem can be shown here, where the dielectric material is replaced with charge densities and the whole space is free space. Rho sub PV is an equivalent volume charge density. Its unit is coulomb per cubic meter, and rho sub PS is an equivalent surface charge density. Its unit is coulomb per square meter. The equation for equivalent charges are shown here. A sub n is a unit vector pointing outward from the surface of dielectric. This equivalence can be proved, but we will skip it for now. Let's look at only in the dielectric region, where charge exists, as shown here. The equivalent problem is this one. In dielectric region, we replace dielectric with rho sub PV. We have both charge rho sub V and equivalent charge rho sub PV in this region, which is now a free space. In free space, divergence of electric field is the volume charge density divided by the permittivity of free space, as shown here. The total volume charge density is sum of real charge and equivalent charge. The equivalent charge is negative of the divergence of polarization, and the real charge is the divergence of the electric flux density. Replacing this relation in the first equation, we obtain this equation. Removing the divergence signs, we obtain the relation between electric flux density, electric field, and polarization. If no dielectric, then no polarization. It reduces to free space relation, which is D equal to epsilon sub 0 E. Materials we see in everyday life, its polarization is aligned and proportional to the electric field in the region. The equation for polarization is shown here. This symbol is called chi, but written as CHI when you want to type. The proportional constant is chi sub E and epsilon sub 0. This material is called linear isotopic material. Linear isotopic material, polarization is proportional to the electric field means the separation between nucleus and electrons is larger or larger dipole moment when the electric field is stronger, as shown here. Replacing the expression for polarization in the electric flux density equation, we obtain this equation. Electric field is a common factor which we can factor out. This left 1 plus chi constant. We call this a relative permittivity, which tells us how much is the permittivity of this dielectric material more than the one for free space. We use a symbol epsilon sub r for relative permittivity. R stands for relative. The equation for electric flux density is simplified as shown here. The epsilon with no subscript is used as a permittivity of a material which includes relative and free space permittivity. It reduced to a simple form of relation between D and E for linear isotopic material. Gauss' law still holds. Divergence of electric flux density is the flux density, and the flux passing through a closed surface is the charge inside the surface. Electric field produced by a point charge Q coulomb at the origin becomes, and the potential is when the whole space is unbounded dielectric material with permittivity of epsilon. Some materials have polarization without any external electric field. For example, a poled PZT or a piezo dielectric. You may search for more details what PZT is in the internet. There are many kinds of special dielectric materials that we might talk about it later.